equal sign, we have an equation, which means that you could solve it. If I asked you to solve an equation like sine of x equals 0, you should be able to tell me, oh, at pi, sine of pi equals 0, or at 0, or at 2 pi. There are specific answers that are true for an equation. An identity is an equation that's true for everything, and we know this is one of our Pythagorean identities. What we're going to be proving are identities. We're going to be proving things that are true. And the big idea is we have to get past this whole equal sign, and I'll show you what I mean by that in a minute. The big thing is just practicing this. I can't stress enough how on your homework tonight you need to try these. If you just look at them and you don't see right away what to do, you got to try stuff, and we're going to go through in a minute. You're going to see all these tips that I have for you. And the very last tip is try something, because I can go through 20 examples with you. There's still going to be a different type of problem that you'll see at some point that you got to do something different. And the reason that we spent a whole week on 5-1 last week is to practice factoring and simplifying and the reciprocals and the Pythagorean ones, because they're going to all come together today. So these next 3 little tips here, the general strategies, this is what your book says that you should be doing, and then I have my own tips that I wrote out on the next slide. But they say, number 1, your proof should begin with one side of an identity. And so, just to kind of look at this one at the same time. So see, they say, let's prove that tangent x plus cotangent x equals secant x times cosecant of x. You should pick one side of this to work on. It's kind of like a geometry proof. You know, in geometry, they would give you, like, the givens, and then they would tell you to prove something, and, like, you would start with the givens, and you would end with the final thing that you were supposed to get. That's kind of like what this is, only they write it in terms of an equation. It's kind of like saying, prove that this equals this. So pick one side to work with. And the proof should end when you make them equal each other. So the good thing is, you know what's supposed to happen. Like, you know at the end, you should make these two things equal to each other. The proof is in between that, which is why it's so important to show me work on this. Do you remember when we did those proof by induction back in first semester, where, like, I would take points off on some people because I would be like, you didn't show me enough steps, you got to show me where this comes from, it's a proof. It's the same thing with this. What's supposed to happen every time is that you get an equal statement. Like, I'm supposed to end with this saying secant x cosecant x equals secant x cosecant x, or the other way is true. That's supposed to happen every time. I can't just grade this because you know how it's supposed to end, right? You remember in geometry where you would write the givens and then you'd write the end statement and you'd just make up the stuff in between and hope you got all your points? I'm onto your tricks. The in-between is the proof. That's the part I have to grade, and so make sure that you show me work there. If you ever ask yourself the question, you think I need to show that step? My answer is yes. If you think you should show it, show it. It's always better to show more work than less work. Okay? So, the tough part is just knowing where to go from here, and that's why we're going to do a few together. You're going to have some on your homework. We're going to do more tomorrow. We're going to do a worksheet on Wednesday, and hopefully by Thursday, you'll be ready for a quiz. How do you know which side to work with? One of my tips is work with the more complicated side, and you might say on this one, I don't know which side's more complicated, but to me, when I see addition, and over here I don't see addition, I think about, I need to turn this addition into multiplication. How could I do that? If you could have a fraction with a common denominator, that's how you can do that. So, can we rewrite tangent and cotangent and make them fractions instead of not fractions? How can you write tangent as a fraction? Sine of x over cosine of x, plus how can you write cotangent? Cosine of x over sine of x. And then on the other side, I'm not going to do anything to this side because this is the side I'm trying to get the other side to turn into. But every step, I'm just going to rewrite this. Secant x cosecant x. I want this to turn into this. And this is really just like what we did last week. Last week, I could have given you this side of the equal sign and just said, simplify this. I like these better than what we did in 5-1 because I know what it's supposed to equal. It's like the odds in the back of the book right there for me. So again, how can I turn addition into multiplication? Common denominator. So my common denominator is going to be cosine of x times sine of x. And again, if you want to show me the step on this one, or just show the work up in the step before that, I'm okay with that. It's like for me, I would say, well, I need to multiply this side by sine of x, and I need to multiply this side by cosine of x. And if you show that work up there, I'm okay with that. If you want to write down here sine of x times sine of x plus cosine of x times cosine of x, I'm okay with that too. And I'm just going to go ahead and say that this becomes sine squared x plus cosine squared x. And again, a lot of this is getting the algebra correctly of the common denominator. Anyone have a question on where I'm getting that from? Just like we did last week, as you're doing the algebra part of it, hopefully the trig part will come into play here. Do we know what sine squared x plus cosine squared x equals? 1, so I could rewrite that as 1 over cosine x sine of x. And then again, I'm trying to make these equal, and I tend to pick one side and just work with one side. But if you wanted to switch to the other side now and change that to equal this, you could. But I'm just going to stay with this one side just for the sake here. If cosine's in the bottom, what would happen if I bring it to the top? What's it become? And what happens if sine's in the bottom? What happens when I bring it up? Cosecant. And you don't really have to, I mean, that's the definition of 1 over cosine. So I don't feel like you have to show, like, how you got that. You're just bringing it up. You know you're done when you get those equal to each other. I like to put a check mark. You don't have to. You put a happy face. Put those 3 little dots that we talked about in the proof by induction. You can put nothing. I don't care. Some people said, like, should I circle this as my answer? I don't think that's necessary because I know that should be the answer. I'm going to be grading the in-between steps is the part that I'm going to be grading. Yeah, you don't have to label your reasoning. That's why your work needs to show what you're doing. Like, I should be able to see from one step to the other how you got there. And that's where, like, Philip was complaining in second hour. He's like, I feel like I'm going to miss a lot of points because I don't show that much work. And I'm like, show it. As long as I can see where one step is coming from the other one and follow it, that's what I need to see. But yeah, you don't have to say by Pythagorean identity or by this. You just work through the proof. How do you feel about that? That's exciting, right? Really not anything different than what we did last week, except for you end up with 2 equivalent statements. I have some tips for you. Are these tips going to always work every time in this order? No. But there's some go-to things. If you get stuck on the homework tonight, my advice is go to these tips and see if you've tried all these things. Some of these are going to be really easy proofs, and then some of them are going to be more difficult. Even though this is printed out for you, I'm going to just go through one at a time just to kind of talk through it with you. This is why I really printed them out, because I knew you would all cry if I made you write all this. The big thing is, although there's an equal sign in the middle of this identity, we're not going to do stuff to both sides of the equation. Like, we're not treating it like an equation we're solving. So you have to work with only one side at a time. I usually say pick the side that looks more complicated, because usually there's more algebra that you can do. You can get a common denominator, or you can factor. Look at the side that's more complicated. But remember, this is not an equation that we're solving, so do not subtract something to one side and the other. Do not square both sides. Do not divide both sides by a trig function. Like, you have to just work with the left side or the right side, and we'll go through that as we do some examples here and try to keep you on track there. This is what we did in 5.1, number 2 here. All these things. When you look at it, if you don't see what to do right away, because some of these are going to be like, oh, that's true. I just do this one step and I can see the answers. Some of these are going to be like 4 or 5 or maybe even 6 steps. You're not going to know right away what's going to happen, but look at it and see if you can factor. See if maybe you can rewrite it to make it fractions that you could add or subtract. See if you could square. See if you could make a denominator that then you could cancel stuff out. Trying to get what's happening there. Also, use the fundamental identities, just like in 5.1, sine squared and cosine squared go together, secant and tangent squared go together, cotangent and cosecant. If you see those, oftentimes you're going to be using those. The other nice thing is remember that you know what the answer is supposed to be. Like, it's like you have the answer to every problem. So if you are working with one side and the other side has all signs in it, try to change that side to stuff with sign in it. Like, try to change it to cosine if it has cosines in it. So use the answer to try to work backwards. And I feel like this should go up here with the identities. Remember which pairs match up, meaning which trig identities match up. Algebra, I've been talking about this since last week. You got to recognize some factoring things, especially if you see the difference of two squares. If you multiply that together, it's going to equal this. Or if you see this, that you can factor it out and cancel something out. Number 6, I put this as the very last step because this should not be your go-to method. Sometimes changing to sines and cosines is the worst idea. But if you can't get any of the above to work, then try to convert to sine and cosine, because you can change every trig function into sine and cosine, tangent, cotangent, secant, cosecant. All the other ones can be changed to sine and cosine, so sometimes that's a good idea. It's never my first try because sometimes it makes the problem insanely difficult. But if you get stuck, that's my go-to thing. And then here's my big thing. Don't bring me a blank sheet of paper, or don't raise your hand today when I give you time to work on homework and write the problem down and say, what do I do next? I don't know what to do. Try something. Look at it and say, what if I multiply these together? This equals this. What if I change the sines and cosines? Sometimes you're going to try something and it's going to not be the right thing. Like sometimes you're going to try something and it's not going to help. You can look at my homework. I have some problems, mostly on tomorrow's stuff because tomorrow gets a little bit harder. But I have some stuff that I try it and it gets worse instead of better, and I just exit out and I'm like, okay, that didn't work. Let's go back and try this way instead. It seems like I always know what to do, but I've worked all these out already, right? When I get a new proof the first time that I get it, I have to try new things too. And so you're not going to learn if you're not trying them. If you don't try the homework tonight, tomorrow when I do some on the board, yeah, you'll get your homework points, but that's sure not going to help you on the quiz that we're going to have this Thursday. So I can't stress enough that these just take practice, just like geometry. Some kids never get the proofs in geometry, but it's because they don't ever try them. You've got to work through them to get this. So I have quite a few not so bad ones on here, hopefully to kind of build you up. Maybe one that's not super easy today, and then we're going to get to the homework and let you kind of work on those. For sure, we're going to be doing some of the homework on the board tomorrow. I can tell you I only have 2 examples in the notes tomorrow. They are big examples. But the plan is I know that there'll be a lot of homework questions, but I don't want to see blank pieces of paper on your homework tomorrow when we're going through this, because it's not going to help you at all. But maybe you're already looking at these. These aren't so bad. Oh my gosh. If they say to verify or prove the identity, here's the nice thing. It will always work. If the directions say prove or verify, they're never going to give you one that doesn't work on those directions. So you know it's supposed to work. And this one's kind of nice. Which side looks more complicated to work with, the left side or the right side? Definitely the left side, which means we want to take this and we want to make it equal 1. There's more than one right way to start this, which is again why when we have a test over this chapter, it's going to take me a while to grade them. That's why it's so nice I'm giving you a quiz on Thursday and I have a whole week to grade all of them to give back to you. Because it takes me a while to grade these because I really have to check the work. And sometimes people come up with a much easier way to prove something than I do, and sometimes people take something that I do in 2 steps and they take 10 steps to do it, but guess what? They still get the right answer, as long as you aren't breaking any laws when you're doing this. So what do you think? Anybody have any suggestions? Colton, what do you see? This is what jumped out at me first. Secant squared and 1. There's an identity that has secant squared and 1 in it, right? 1 plus tangent squared equals secant squared. You got to know these. So if that's true, what does secant squared minus 1 equal? Tangent squared. You see that? If you subtract 1 over. And I'm totally okay with you substituting Pythagorean identities without showing the work. If it helps you to write that out there, you can write it out there. But if you just change this to tangent squared, I can follow that because I know my identities. And Colton did this all in 1 step. Last hour, we left the cotangent, we changed that, and then we did another step and changed it to 1 over tangent. But Colton kind of saw ahead of what was going to happen there. Can I now cross these tangents out and get 1 equals 1? That's not a long proof. We did it all in 1 step there, really. But that works. That's good enough work to show me. But notice, you got to know those identities. If you don't know the identities, you're going to have no clue how to do these problems. Number 3 was one. In second hour, they really wanted to do something to both sides. Like they wanted to subtract 3 from both sides or subtract 4 from both sides. You're not allowed to do that. You have to pick either work with this side and make it equal this, or work with this side and make it equal this, because you're trying to prove that they're equivalent, which means you're not allowed to do stuff to both sides. Does one side jump out as being more complicated than the other side? They both look about the same to me, which means sometimes it doesn't matter which side you pick. This one, it kind of matters. I mean, could you turn one into that? You could, but it's kind of a crazy thing to do. It doesn't matter which side you do here. I'm going to do it from both sides just to show you that it works. But if I choose to work with this side, in my head, I'm going to be thinking, can I change tangent squared into secant squared? And again, right up here, could I replace tangent squared with secant squared minus 1? And I could. And I could say tangent squared is the same as secant squared minus 1 plus 4. And again, it's really only a 2-step proof here, because then I just take negative 1 plus 4, and I get secant squared plus 3 equals secant squared plus 3. You don't have to write this part down if you don't want to, but what if I wanted to pick this side and turn it into this? So rewrite this here. If I picked to work with the right side, I would ask myself, can I replace secant squared with something that has tangent squared in it? And it's the same identity, it's just writing it differently. Secant squared equals tangent squared plus 1 plus 3, which means I end up with tangent squared plus 4 equals tangent squared plus 4. Both of those are correct. It just depends on which side you choose to work with. Which is, again, why sometimes it's almost ridiculous that I even make an answer key out, because everyone's proof can be a little different, and especially if you pick the other side to work with. Questions on that?
It's like one of those things that's easy in here, and you get home.
There are some that are a little bit harder on homework, and these are the first ones. We're going to do some more. But yes, they're going to get harder. Tomorrow, they're definitely going to get harder. I can tell you the 2 examples that I have to do tomorrow are probably like 6 or 7 steps. I tried to pick ones today that aren't super bad to do, but towards the end of the homework, I definitely gave you some to see if, now can you do this one? And I know we're going to do probably, I think there's 11 homework problems. I'm guaranteeing we're going to do at least 4 on the board tomorrow, maybe 5, depending on how we're doing on it. But I'm hoping that you'll at least try them and get somewhere. We had about 15 minutes in second hour to work on it, and so they got to some of them that they were able to think through it, and then I can say, what do you think you could do now? And they were able to get through about half the homework. So we'll see. But definitely you're right. These are easy ones, right? They're not all that easy. I do want to do this one. I didn't used to do a question like this, but I gave you some on the homework and it threw people, because the directions on the first 3 of the homework are this. They say, tell whether or not f of x equals sine of x is an identity to this, which basically means the directions here don't say prove that this is true. Basically, they're asking you, does tangent x over secant x equal sine of x? And I'm going to put a question mark above there, because they're asking you, is it true? The answer is yes or no. If the directions say prove, they will always work. But this is the first ones on your homework today, which are not proved. And so you just got to see if it works out. If you can see that it works out, then you say yes. Maybe you can even show that it works out. If you start to work it out and you can see that it doesn't equal sine of x, then you just stop and you say no. Okay? So, what can we do on this? First of all, what could I do with secant? I'm going to hold off on you, Colton, because I'm going to try to make someone else do something. Sam. Well, secant's already on the bottom, right? So you're right. We could write 1 over cosine, but try to make it less complicated. Instead of writing 1 over cosine, if secant's on the bottom, what happens if I bring it up? Does it just become cosine? You with me on that or not?
Yeah.
It's fine to write 1 over cosine, then you just flip it up. I'm just trying to make it not a complex fraction. Whenever I see a trig function on the bottom, I know I can bring it up and make it the reciprocal. What else could I do? What is tangent the same as? Sine over cosine. So is this going to be true? Does that just equal sine? Yes. If it doesn't equal sine, then you say no. And there's 3 of those on your homework. And again, when you look at these, I think the problem is that people want to be able to, like someone in second hour said, I don't want to try something and then it be wrong. Like I don't want to have to erase or scribble it out. But that's going to happen sometimes. So you want to just, if you can't see right away what's going to happen, that's going to happen a lot. They're not going to always be just one step. You want to just think about which side should you work with. That should be your first step. Which side do you feel like you have more that you can do? The left side or the right side? Left side. Because I see that there's parentheses there. I think that looks more complicated. And then it's just decide to do something. And I don't care what step you do first, as long as you're doing a correct math step. To me, if I see parentheses, I feel like multiplying would be a good step. Do you agree that I can multiply? Maybe you see something else that you want to do first. That's okay. But if I was going to do this, I would multiply this and say that's cosine x times tangent x plus, this is just going to be 3 things now, cosine x times sine of x times cotangent of x. And you might say, well, that looks worse than what we started with. But again, think about the end result that we want. My end result is 1 thing plus 1 thing, which means by getting rid of this multiplication, we've at least changed this to something plus something. I'm hoping that this somethings will cancel out. Something else to look at, my answer only has sines and cosines in it. So if my answer only has sines and cosines in it, you think it would be a good step to go through and change anything that's not sines and cosines into sines and cosines? Yeah, and then hopefully something will happen. Tangent changes to sine of x over cosine of x. Cosine x times sine of x, and cotangent changes to cosine of x over sine of x. And again, this step right here is probably the step that if you know what stuff's going to change to, you might not want to show that step. But I think it's a good step to show. It shows me that you know what's happening. Because if you skip this step and you just go straight to the answer, I would say, how do you know that that's what it equals? But showing this one step, I could say, look what happens. My cosines cancel, and I'm left with sine of x. And over here, my sine of x's cancel, and I'm left with cosine times cosine, which is cosine squared. And isn't that what I want to get? Again, not terribly long, but you got to show me something that shows me how you know that that's true. Questions about this? You have about 20 minutes to work on this. Again, what I want you to do is start them. Don't write the problem down and say, tell me what to do, because that's not going to help. If you try something and then you get stuck, then ask me and I'll help you. But don't just say, how do I start this one? How do I start this one? Because I'm going to say, you tell me what do you see you could do. So this is 5-2 day 1. 5, 7, and 10 are the ones that say, does this equal sine of x? Right under there, sine of x question mark. So just look at them, try something, show something to see if it works or not. And then 12 through 33 multiples of 3. I think that's 8 problems to start on, and we'll see where we get with it. And again, I know that we'll do some of these tomorrow, so don't freak out if you don't get them all to work out, but try them is what we're looking for on this.